Hello, we're going to talk a little bit about graphing polynomials today. And two of the characteristics of a polynomial are characteristics that we're already familiar with, and that's our x and y intercepts. Remember that to find a y-intercept, we plug 0 in for x. To find an x-intercept, we plug 0 in for y. But what about this bounce, wiggle, and relative maximum or minimum? Well, a bounce occurs when we factor our equation and we have a factor that has an even multiplicity. So for example, x plus 2 to the second power, or x plus 3 to the fourth power. I guess it needs to be even. And what happens is we get a bounce on the x-axis there instead of an x-intercept. So it hits the x-axis, but it doesn't go through there. I guess it's still an x-intercept, it just doesn't cross the x-axis, it bounces, much like a ball on the floor does. So how about a wiggle? Well, a wiggle occurs at an intercept when a factor has an odd multiplicity. So, for example, x to the third power, we know what that looks like. In some places it's been described as the disco graph. Where it crosses 0, where it crosses the origin, that's what a wiggle is. It continues on its way, it's increasing the whole place, but it kind of veers off, but continues to increase. So I've got a picture here of a wiggle at positive 1. So when we factor it, what we'd have for a factor is x minus 1, but we'd have x minus 1 to the third power, or x minus 1 to the fifth power. So we've got an odd multiplicity there. How about our relative maximums and minimums? Well, those refer to the highs and the lows in between the x-intercepts. If you look on the graph, you can see I've marked a relative maximum at 2 and a relative minimum at about -2. Sometimes these are called local maximums and minimums, but what we do is use test points to find them. The test points we pick will be points that are in between some x-intercepts. So for example, we might pick a test point of -2 and a test point of, say, 1.5 or +2. So let's do this with an actual example here. F of x equals 2x to the third power plus 5x squared minus x minus 6. We're going to find our y-intercept, just like we've been doing. We want to find f of 0. Turns out to be -6. How about our x-intercepts? Well, we replace 0 for the y, which essentially means we need to solve this. Now, if this were a squared, a quadratic, we could factor this or use the quadratic formula, but it's a cubic, and it doesn't factor by grouping, so you need some information that you don't have. So I'm telling you that -2 is a 0, and you have to find the rest. So we're going to use synthetic division to find out what our coefficients of our answer are. So the reason we use synthetic division is so we can find out the 2, the 1, and the -3 part of our answer, because remember that translates into a 2x to the second power plus x minus 3. Now if we factor that, we can find our remaining zeros. It does factor into 2x plus 3 and x minus 1. Set those factors equal to 0, and we get x-intercepts, or zeros, at -3/2 and also at +1. Now remember, I gave you one of the zeros already at -2. So over here on our graph, we have all 3 zeros listed. Now how about bounces and wiggles? Well, I have 3 factors, 2x plus 3, x minus 1, and x plus 2, which isn't written there, but that comes from this 0 of -2. None of those factors has a multiplicity that's even. Those are all to the first power, so it doesn't have any bounces. How about wiggles? Well, in a similar manner, there are no wiggles because I don't have any factor to the third power or to the fifth power. So how about the relative maximums and minimums? What is the graph doing in between these x-intercepts? Well, that's where test points come into play. A good test point might be -1 here. It's in between our y-axis and the 0 at -2. So when x is -1, y is -2. Another good test point would be -1.75. And if we notice, when x is -1.75, our y value is positive. So this graph comes up over the x-axis just a little bit right here. I might want to check more test points just to make sure I understand what this thing is doing. So if I check f of -3, it's down here at -12. If I check f of +2, it's way up here at 28. So I can finish drawing my graph with my x and y intercepts and my test points.